John, so I will be taking a slightly different approach on what the Geek does in the battery technology space, as I won't be focusing on what graphene does, but what the Graphene at Manchester network has done with graphene to promote a green energy future. So what we'll focus on is what is the current problem at the moment. We are currently using 80% of our energy reserves based on fossil fuels, and we need to change the strategy to be able to deliver the net zero goals. So the priority is to try to push these renewable energy systems. Now, in an overall view, graphene and its other materials will be able to deliver a significant role in proving a net zero future, and there's lots of work which will be discussed through the other partners and the other managers in later time. But what I'm focusing on is on the battery space. So when we talk about batteries, the primary thing we think of is electric vehicles. And that is because there's a significant drive to move away from the internal combustion systems that we have at the moment. And looking at the numbers, we are expecting a $400 billion a year industry just in battery markets, with about 260 billion being for EVs itself. Now, the mobile market uses lithium-ion batteries because it's high charge densities and capacities, but it has a significant number of flaws, which includes its safety, its environmental and ecological, and significant supply chain issues. So what we need to do is we need to be able to comprise this battery pack here using a more sustainable approach, using cheaper materials, and being able to deliver it within a small package to allow for cars and EVs to develop further. So what we've done in the Geek is we compile this sort of roadmap and what the battery technologies are going to be in the future, particularly in the mobile market. And primarily, we're at this point here, which is the lithium-ion batteries, standard formations which are used at the moment. And you can see that for generational changes, you're going to need to have a lot of changes and improvements in each of the components of the batteries. You'll be able to see this a lot in any part of the labs we look at the moment, because this is what we try. And we can see that by playing around with the chemistry here and adding graphene into it, we can show small improvements on the capacity, the performance, and on stability of batteries by adding graphene to it. But as the manager of the energy team here at Geek, my clear point to you is don't focus on graphene on battery systems that are developed at the moment. What we want to do is develop the next generation battery system, because those 10% improvements, 20% improvements now, after qualification and validation and implementation into the market, you've lost that benefit because there's going to be markets that other technologies that are catching up. So graphene's importance is in the next generations. And what we can show is that in the next generation systems, they're looking at trying to improve the capacity of battery systems that are from current generation, which is lithium-ion, by improving the cathode compositions and using new chemistries, or looking at developing new electrolytes which allow for high amount of capacity that can be transferred and migrated, as well as the anodes. So 3 areas we need to look at: cathodes, anodes, and electrolytes. Now, the current trends in how they're doing this are shown here, and there's 3 key problems, one with each one. For the anode systems, we're moving towards silicon, but pulverization means that batteries do not last anywhere near as long as lithium-ion batteries at the moment, which uses graphite. For the new cathode chemistries, which are based on lithium sulfur, this shuttling effect, which is well known in the battery makers, significantly reduces the lifetime, so you can only run batteries for hundreds of times rather than the thousands of times you need for a car motor. And when we're moving to the electrolyte, we want to move to solid-state batteries, which are more resilient, safer, and can allow for a better operation, but they are relatively fragile compared to liquid phase systems. And all I'll show you is how graphene is seen to improve these performances. Incorporating it as a core development strategy for these materials will give you improvements in the stability of silicon anodes, in the actual implementation of lithium-sulfur batteries, and to stabilize and in some cases heal solid-state batteries so that they can actually run to levels that lithium ions are and hopefully perform at a better rate. Now, when we're talking about battery sectors, we're also looking at the stationary battery market. We are moving away from the uses of fossil fuel systems such as coal, oil industries, and these are dictated by these standards, regulations, and initiatives that are played out. And we're looking at about a $65 billion a year market by 2030. Now, how does this work in the real world? Currently, our energy generation system is centralized. We have one big plant that generates all the energy and then distributes it to the required endpoints, which has significant costs in implementation, transmission, and delivery of these systems. What the smart grid future is looking for is to try to decentralize it and build clusters of energy storage, where you can have renewable plants such as wind or solar powering small areas, which then allow for a smaller transmission system, and also the contribution of energy from the consumer. So it's not a one-way process. Now, I've come up with a few scenarios where this will work. So if you're looking at a smart grid system, you can see that there are battery technologies at home, in industry, and at grid scale. And we've come up with 3 scenarios which are key to being able to deliver a battery future within the smart grid. The first one is getting energy from non-renewables at the moment. There's a high cost at peak times. But everyone that works in industry, everyone that works at home or uses electricity, most of the time they use it during the peak hours. What if you could able to store the energy at off-peak hours where you have a significant reduction in cost and then redistribute that power, avoiding the need to use the generators during peak hours? You are making potentially current costs about 60% of the energy costs just by doing that process alone. What about renewable systems? So one of the biggest issues, which I don't think is as well known for wind farms, is that it doesn't run 100% of the time. So you'll see a lot of wind farms that are shut. The primary cause of that is grid curtailment, where the grid is full of energy. There's been studies done through MMU, and they found that approximately £1 billion of energy is lost as wind farms are shut during this period. So what's the solution? You can build a storage system that will collect that energy when it's not needed. And this could be also done in offices and in home-based energy generation systems. And then when the grid is back to being in high demand, redistribute it, providing a cost to consumers. And then finally, in the scenario which we're seeing quite regularly in both natural and unnatural situations, where we have a power cut, we have an emergency situation where there is a loss of power. You can implement the energy system, storage systems you have in home and industry, or you can implement mobile systems that will allow for emergency systems to operate and allow for at least the city to run at some capacity. Now, incorporating all of these will provide considerable savings in the long term for industry partners, for the grid, as well as for consumers to be able to deliver the net zero future. Now, when we're talking about stationary storage, lithium-ion batteries is not the way to go. It's got high energy density, which is great for cars, which needs a small package as possible. But when you talk about stationary, you're happy with a larger system that will be able to store as much energy as possible. So when we're looking at stationary storage solutions, we've got a number of processes we have here, and they're all coming into fruition in the next 5 years. And what we're hoping to show here is that the Geek, as well as this ecosystem, are delivering in these areas. So first, we're looking at redox slow batteries, which are primarily just liquid batteries that can operate at non-volume limit capacities. It just depends how big your area is. The one big problem we have at the moment is the membrane technology. It's very expensive, uses Nafion, which is a PFAS at-risk material, and the lifetime of these batteries aren't great because the membranes do not work as well. One of our partners, Heliogen Power, who joined us at the start of 2024, they've developed a membraneless energy storage system, redox slow batteries technology, which utilizes graphene. They've recently obtained a 3 million grant from the German Spring disruptive technology arm of the German government to develop a 1,000-litre pilot scale reactor. We're working with a number of partners on sodium-ion batteries or saltwater batteries, which one of the main drivers is to remove the need to use lead batteries, which has its significant environmental issues. When we move into sodium ion, we can actually see that there's a significant improvement in energy capacity, as well as safety and efficiency improvements. Now, when you're looking at how to implement this, it doesn't work the same as lithium ion. The storage of lithium can be done through graphite, but sodium ions struggle. What graphene can do is it can implement a way to store sodium ions in a similar manner to lithium and allow for energy generation to occur. Now, sodium ion battery systems are great for stationary, but as you can see, one key issue which you can't actually see is that the actual capacity of sodium ion is low compared to lithium. So it doesn't have the capacity to meet mobile markets, but it will be the gateway for new metal technologies that will replace lithium ion that can achieve 4 or 5 times the amount of energy capacity that's able to be delivered within a system. And then finally, we're looking at a new class of materials, which some people have seen, which is MXenes, where instead of looking at, which is done by our partners at Nanoplexus, which instead of looking at graphenes, which are relatively a strict set of materials which can be functionalized and modified, you're looking at a library of 70 materials which can be tailored to each application. So there are a number of materials which are suitable for battery technologies, and Nanoplexus are the largest suppliers of MXenes, and they produce it in the labs within the Geek at the moment, and they are developing battery technologies which are looking at next generation supercapacitors and battery systems. And then the last point I'll make is, of course, net zero. You're looking at trying to build a sustainable platform. Now, battery storage system covers most of the 4 points you see down here. The 2 it doesn't cover at the moment are how to recycle batteries, as we end up with battery graveyards at the moment from EVs that have either degraded or been in an accident and are too damaged to repair, and the increasing demand of materials for battery technology. And you can see that we're significantly increasing the amount of metals, rare earth metals, and lithium we need. So the quiet challenge for many is to try to understand how to build a circular economy. So being able to use the waste materials and bring it back into the markets as a commodity. Water Cycle Technologies, who is another partner of ours based here at the Geek, have a platform where they've been able to produce, to obtain waste battery material, and through a clean process are able to extract materials where they can get 75 to 95% materials back through reuse in the markets. Now, the important thing here is they're actually working at 1 ton a day processing capability, and they're looking to scale up. So it's not a technology that's in the future, it's something that can be delivered soon. So just a few take-home points. So we're talking about how electric battery vehicles are going to need to support net zero pushes, as well as how graphene can implement improvements in smart grid systems, as well as trying to build a circular battery life cycle. If you have any questions, I'm happy to answer them now, but this is the Graphene Manchester ecosystem in a snapshot, but I'm hoping to show that the ecosystem is actually working within the energy sector as we speak.